Hello, everyone. I am going to go ahead and get started. Um, I'll just say a little bit about myself before I begin. So my name is John Rendina. I received my MPH from the CUNY School of Public Health in biostatistics, and I received my PhD in social psychology from the CUNY Graduate Center last year. I am a research scientist and the senior data analyst at HIV Research Center affiliated with Hunter College called the Center for HIV Educational Studies and Training, or CHEST. And just so people know, CHEST is always looking for new interns, and we have opportunities to conduct capstone work here and or a master's thesis. So if you ever want any more information about that, you can go to our website, which is www.chestnyc.org. And we have an entire section of the website dedicated to our internship program. Other than that, just a quick orientation. Some of you may have already used the Hangouts app before, and some of you may not. The app does have a little bit of a lag. So if anyone wants to use the Q&A function, I'll be checking that periodically to see if anyone has submitted questions. That's the best way to get in touch with me. You could also attempt to send me an email during the online tutorials, but it's possible that I will not receive those or may not see those as soon as they come in. But you can use the Q&A app that's part of the Hangouts, and I will be attempting to try to keep an eye on that. Other than that, I'm going to go ahead and get started. We're going to be focusing on a Excel tutorial today, so learning a little bit more about how to use Excel. It will be, some of it will be, repetitive with the lab, but we're hoping that when we present this information to you multiple times and in somewhat different formats and with different people explaining it, that hopefully over time that information will really sink in. Okay, so what you can see here is that I have a spreadsheet, and as you can see, the spreadsheet is made up of multiple rows, and Excel, the rows are always numbered, and then it also has multiple columns, and in Excel, the columns are always lettered. And so anytime you are referencing a single cell, you're going to be referencing a combination of a column letter and a row number. So as you can see up here in the corner, the very first cell is cell A1 because it's in column A and row 1. And no matter where you go in the spreadsheet, it's going to show you right up here what the name or location of that cell is. In addition, you have the function drop down here, which will give you a link to all of the different functions that you can use in Excel. So if you just go here to the all, you can see that it will give you a list of all the different Excel functions. I do have a website that gives some of the more commonly used functions, and I tried to post that earlier, and unfortunately Blackboard was not cooperating right now. So I will try to give that, I will try to post that later this evening if Blackboard will allow me to post tonight. I'm noticing that my computer is doing a little bit of a funny kind of jittery thing, so I'm going to turn off screen sharing and turn it back on real quick. Okay, so we'll see if this works better having it with the full screen being shared. Okay, so the first thing that we want to do is notice that I have created a little bit of a table here with some data in it. And so we have participant ID numbers. So each row is a different person, and each person has an ID number that goes from 1 to 20. Then we have a column with gender, and so each person in this data set is either male or female. We also have a column that indicates the person's race, and so we have white, black, and Latino participants in this data set. Then we have participants' ages, we have participants' heights, and we have participants' weights. And so the first thing that we want to do is think about what the different variable types that we have here are. Now, of course, the ID variable is not really a variable of interest. The ID variable is really only used if you were to sort and then you want to resort them back the way that they were, the ID variable will help you do that. And so the first thing I'll show you is how in Excel you can use the sorting and the filtering techniques. So what I'm going to do is highlight across the different variables. So the things over here and the things down here are things that we're going to be working with later, but really it's just this table right here that we're working, that has the data in it. And so we're going to take these columns, and I am going to go ahead and put on the sort and filter option right here. So if you see here, I have this drop down called sort and filter, and it has this filter option. If I do that, you'll see that it creates a little down arrow for all of these different columns, the header of all of these different columns, because I had highlighted those. And so now what I can do is I can just click on, for example, the gender, and I can say sort A to Z. And what that's going to do is it's going to take everything in this table, and it's going to sort them based on the gender that is written in here. So it's going to sort them. If I do A to Z, then it's going to put females first and males second, because F comes before M. And if I do Z to A, it's going to do the opposite. It's going to put males first and females second, because M comes after F. So I'll sort A to Z. And then as you can see, what it does is it puts all of the females here on top and all of the males here on bottom. And the important thing to keep in mind is that when you sort by something, it's only going to sort to the extent that it has to. So other than rearranging this, so it kept first of all, it's important to know that it kept everything in line. So the first participant who was in this first row was participant 1, and that person was male, white, 69 years old, 73 inches tall, and 304 pounds. And that data moved with that person. So because we have these sorted, we've already told it which variables to sort by, it expands that sort so that it keeps all of the males with their original data and all of the females with their original data. The next thing to note is that once things are sorted by the sorting variable, so female and male, they retain their original sorting within that group. So within females, they're still sorted ascending from 2 to 19, and within males, they're still sorted ascending from 1 to 20. So they're still in smallest to largest order by ID within the category that we've sorted by. I'll also just show you that you can also, in addition to sorting or instead of sorting, you can choose to only display certain features. So if we only want to display the females or only want to display the males, we would uncheck one or the other. I'm not going to do that because it will actually hide some of these rows, and these rows, as you can see, have other information over here. However, if this was an Excel spreadsheet that only had this data sheet in it, you could do that and it would then hide all of the females or all of the males. So I'm going to go ahead and sort this back by ID again. And then we can go ahead and move on to the next task. So the next thing that we want to do is we want to calculate the BMI. And as you can see here, I put a note that the BMI is equal to the weight divided by the height squared times 703. And the first thing that you need to remember is that Excel is going to utilize the mathematical order of operations. So some of you may remember the order of operations. Some of you may not have heard about the order of operations since high school. Some of you may have taken some math classes in college and had to think about that again. And some of you may have even taken some math classes in grad school. But just remember that the order of operations, the initials are P, E, M, D, A, and S. And P stands for parentheses, E stands for exponents, M stands for multiplication, D stands for division, A stands for addition, and S stands for subtraction. So this is the order in which Excel is going to do things. So if I do equals the weight divided by the height squared. So actually, let me just show you. Squared is this caret, which is shift and then the 6 key. So 2 to the second times 703. Now, in this case, that is fine, because it's going to then evaluate this as So it's going to do parentheses, which I didn't put any in there. So the next thing it's going to do is exponents. So it's going to do this first. It's going to do e2 to the second, and then it's going to move on, and it's going to do multiplication. Actually, so in this case, we might get the wrong answer, because it may or may not do f2 divided by e2 times 703. So let me just see, equals the weight divided by, oh no, so either way, it's actually going to be the same thing either way. So we don't have to worry about it in this case. But if we did have something where it was weight divided by height and then that entire quantity squared, we would need to make sure that we put parentheses around that. So the point of all of this is just to say, pay careful attention, because a lot of times the mistakes that people make are because they're not using parentheses appropriately, and it's executing the order of operations instead of executing the order that the person actually intended to utilize. Okay, so now we have our formula already input in here. And as you probably saw in the lab, what you can do in Excel once you have a formula put in is you can then put your cursor over that box, and you'll get this little cross, a black cross. And then when you have that, you can just drag down. And what it'll do is it'll take that formula and apply it to each of the cells. So as you can see, it took the original formula and it moved it down so that the cells that it was referencing were the next ones. And then the same for here, it took the formula and it moved it down so that the cells that it was referencing were next to it. So whenever you pull things down, it pulls the formula down by one cell as well, so that it's referencing one cell lower than you were originally referencing. The same would be true if we had done something here and then moved it over. It would then move the cells that it's referencing over. Okay, so now that we have the BMI calculated for everyone, we're going to go ahead and calculate these statistics. So we're going to calculate the mean, the median, the mode, the minimum, the maximum, the 25th percentile, and the 75th percentile. And so the mean is the arithmetic average. So it's the sum of all of the numbers divided by the total number of cases. The median is the middle. So if we were to sort age, for example, from lowest to highest, then the median would be the middle of this, and there are 20 cases here, so what it would actually be is the average of the 10th and the 11th cases. The mode is the most frequently occurring. The minimum is obviously the lowest, the maximum is the highest, and then we have the 25th and the 75th percentiles, and the 25th and 75th percentiles are similar to the median. So the median is considered the 50th percentile. It is the exact middle of the ordering of the data. The 25th percentile corresponds to whoever is the 25th. There are 25% of the sample below them and 75% of the sample above this number. And the 75th percentile, it has 75% of the sample below this number and 25% of the sample higher than this number. And the easiest thing to remember when you're thinking about percentiles is probably standardized testing. So oftentimes you'll receive results of standardized testing and it'll tell you what percentile you're in. And what that percentile means is the percent of people below you. So the 25th percentile has 25% of people below it. The 75th percentile is the number that corresponds to 75% of people being below that number. Now, the first thing to notice is that what we have here are two nominal variables. So a nominal variable or a qualitative variable is a variable that doesn't have a number. Now, in SPSS, as you'll see when we get to that, all of these variables will have numbers, but we'll be able to assign value labels to those. In Excel, we can just give them we can just put in the actual text, but in SPSS, we'll typically be using numbers to correspond to these groups. However, the numbers, if were we to assign numbers to this, so we could make males 1 and females 2, and that would be totally fine. If we did that, those numbers wouldn't have any meaning. Males are not 1 of something and females are not 2 of something. Females are not twice as many things as males or 1 more of anything than males. At least not typically. And so the numbers in this case don't have any meaning. So these are what we call nominal variables. They're variables in name only. And so none of these statistics will actually apply to those groups. So I'm going to go ahead and black that out. And so you see what I'm doing here is that I have this little bucket, and this bucket tells Excel to fill in the cells that I have selected with a certain color. So in this case, I'm going to black those out, because these statistics don't apply in that case. All right, so then the next thing we're going to do is calculate the average of the age. Now, there are two different ways that we could do this. I'll show you the first way with this variable and the next way with the height variable. So the first way is we can take the sum of all of the variables that we have here, or all of the cases that we have here. So we do sorry, let me back up. So we do equals to start a function, and then we start typing our function. So if we want to add things together, then we do the sum. And you'll see here that Excel pulls up this little menu to start showing you all of the possible choices you could make based on what you've typed so far. So if you don't know exactly what you're looking for, you can start with one word and then, or start with one letter and then keep filling them in. So we're looking for sum here. So then we're going to open parentheses and we're going to drag across all of the cases. Then we're going to close that parentheses. And then in order to take an average, what we need is the sum of all of the cases divided by the total number of cases. Now, in this case, we already know that we have 20 cases. It's a very easy thing. We don't have too many of them, and they all have ID numbers that go from 1 to 20. So I can just type in 20 here and get that average. And in this case, the average age is 46.2. Another thing that you could do here is use another Excel function. And that function, by the way, notice that when you begin typing, it shows you everything nicely here. But oftentimes it's easier to see everything if you look up here at the function bar. Okay, so if I want to get the count, which is the total number of cases that I'm looking at, I can do count, which is another Excel function. And then I'm just going to ask it to count the same exact set. And notice that we get the same exact answer, because what it's doing is it's counting essentially how many rows or how many cells we're looking at here. And we know that that answer is 20. So you can either do sum divided by, if you know the exact count, then you can just put in that count. If you don't know the exact count, you can use this function, and then you can highlight the cells that you're talking about. The other way of getting a mean would be to simply use Excel's average function. And so it's not called mean in Excel, it's called average. But you can begin typing, and then you'll see that average pops up. And then always notice that when you open that parentheses, Excel is then going to tell you what it expects to see inside those parentheses. It also gives you a link here, which will open up the Excel help and tell you more about the function, so that if you don't understand the exact syntax, it gives you all kinds of information about that. That's if you click on the actual thing that pops up in this notification thing. And so here it's telling you, what numbers do you want to take the average of? Give me the list of numbers. So if you could simply just put in 5, 6, 7. So if you didn't have a list of variables already in the spreadsheet, then you could just start typing in variables. But in this case, we do have a list, and we want to take the average of that list. So we're going to take all of the heights, and then we're going to simply close, and it's going to do that automatically for us. And it would do the same thing if we had used the formula that we used over here. And now what we're going to do, since there's no reason to type that over and over again, is we're simply going to take this and we're going to drag it over the columns. And so this is automatically then going to, so what we see here is that here the function was average of E2 to E21. Again, column E, rows 2 to 21. And then if we move over, we see that it automatically changed that for us. So we moved over, and so Excel automatically moved that box of cells over. So we moved over one cell, and so Excel moved the function over one cell. So now we're F2 to F21. Again, column F, rows 2 to 21. And same thing here, it automatically updated it to be G2 to G21, column G, rows 2 to 21. All right, the next thing that we're going to do is calculate the median. Now, if we had sorted these data, and we could sort these data, so let's just go ahead and sort smallest to largest. We are going to see that the median is going to be halfway between 47 and 49. So the median in this case should be 48. I'm going to go ahead and resort that by ID, and then we can go ahead and do equals the median of these ages, 49.5. So maybe we did something wrong here when we sorted. Oh, I'm sorry. I looked at the wrong ones. So I did 10 and 11 because I was looking for the 10th and 11th case, but I forgot that there was a header bar here, which is the first case. So I actually needed to do 11 and 12. So again, when you have an even number of cases, it's the average of the two middle cases. And when you have an odd number of cases, it's just the exact middle case, the value of that case. So in this case, it's 49.5 because the 10th case and the 11th case, which correspond in this case to rows 11 and 12 because of the heading row, it's the average of 49 and 50, which of course is 49.5. Okay, so then again, we can just take this and we can drag it all the way across and it will update all of those things for us. We then want the mode, or the most frequently occurring. And you'll notice here that if we start typing mode and then we go to open parentheses, we're going to run into a problem because it has two different options for mode. We can have mode.mult or mode.single. And if you look here, it gives you a description of what this is. And what this tells you is something that we do not want this. What we actually want is mode.single, because if we click on that, it tells us that it returns the most frequently occurring or repetitive value in an array or range of data. That's exactly what we want. We just want whatever is the most frequently occurring is what our definition of a mode is. So we're going to type .sngl, and then we're going to select. And we see that 50 is the most frequently occurring. Now let's go ahead and sort this again by age. And you can see that 50 is, in fact, actually the only number that occurs more than once. Okay, so now we're going to take this and move this across. And so, interestingly, you'll see here, Excel tells you it's not applicable. The mode is not applicable in this case. And the reason for that is that if you look at this, neither of these numbers actually has, or neither of these variables, weight or BMI, has a number that repeats itself. So all of the numbers in these lists are completely unique. And so it's not possible to create a mode for those because there is no variable that occurs more than once. All right, the next thing we want is the minimum value, and that is just min is the function for that. And we'll just again take this. And we already knew that that was 20 because we've sorted it several times, and every time we sort it, that ends up as the first row. And so that is our minimum value. And then we'll just take this and move over. And so 62 is the minimum height. 141 pounds is the minimum weight, and 21.4 is the minimum BMI. Then we want the max, which is just equals max. We select all of them. Close parentheses. So 71 is the oldest person in this data. We'll move this over. The tallest person in this data set is 79 inches tall. The heaviest person in this data set is 332 pounds. And the highest BMI in this data set is 55.24 pounds. All right, now we want the 25th percentile. And so the function for this is, I believe, percentile. And so it gives you two different options again. So you want to look at the options that it's giving you. It can give you either the kth percentile of values in a range, where k is a range 0 to 1 exclusive, or it can give you a percentile which returns the kth percentile values in a range where k is in the range of 0 to 1 inclusive. In this case, I'm going to choose an inclusive percentile. And what this means is, should it include the value that is at that percentile, or should it exclude the value that is corresponding to that exact percentile? I'm going to ask it to include that percentile. Oh, I'm sorry. So as you see, it's telling me the first thing it needs is the numbers. But in this case, the percentile, it also needs more information. And so in this case, k corresponds with the percentile. So here, what we want is the 25th percentile. So we type in 25 for k. And also just notice, it bolds what you're currently working on. And if you have any questions about what you're supposed to put in there, you can click on that link as well. So here I need to put the array, and then I need to put a comma, and then it automatically knows that now what I need to put in there is k. And if I don't know what k is, then I can go ahead and click on k, and it will open up the help for k, which will give me more information about that. But I know that k is the percentile, so I'm going to type in 25 here. And we got an error. So let's see, what is the error that we're getting? Number error. It's possible that I need to do 0.25. Let's see. Yep, so that was the error. Sorry about that. The percentiles always have to be between 0 and 1, which I actually had already read earlier and forgotten about. 0 being 0 percentile, 1 being the 100th percentile, and 0.25 in this case being the 25th percentile. So in this case, 25% of the sample is 31.75 years or younger, and about 75% of the sample is 31.75 years or older. About 25% of the sample is under 66 inches tall. About 25% of the sample is under 182 pounds, and about 25% of the sample is under 26.9 BMI. We're going to go ahead and do the same thing here. Well, actually, let me go ahead and take this and move it down and show you what that does. So if I take this and move it down, well, first of all, I want the 75th percentile now. So I'm going to change this 0.25 to a 7. But the other thing that I want to show you is that because I've moved it down one, Excel has naturally moved this box down one. So you can see that this row is no longer included, and we now have one of our empty rows included. So the way to fix that, well, one way to fix that, fixing it manually, would be to just take this box and move it back up. Move it back up so that it's going around our full range of data. And then that will fix the range. And now, as you can see, the box is around the numbers that we want. And then now that we've already fixed the 0.25 to be 0.75 in here, we're all set. So the 75th percentile in this data set is 59, meaning that about 75% of the sample is under age 59, and about 25% of the sample is over age 59. And what we have here is sometimes called the interquartile range. So the 25th percentile to the 75th percentile is what's called the interquartile range. And this is often presented in conjunction with the median, which again is the 50th percentile. We can move this formula over now, and it will give us the 75th percentile for the other variables. So in this case, the 75th percentile for height is 72 inches. The 75th percentile for weight is 287 pounds. And the 75th percentile for BMI is about 39. And you can see here, for example, that the 25th percentile is 182. The 75th percentile is 287. So the range from the 25th to the 75th percentile is about 100 pounds, 105 pounds in this case. Okay, so now we have all of these descriptive statistics filled in. By the way, just to remind you, the Q&A is enabled. I'm not sure if you can see me doing this over here, but this is where your questions will pop up if you have any. So if I'm going too quickly, if you're having trouble hearing me, if you're having trouble seeing what I do, go ahead and add a question in here. And I will go ahead and try to answer that for you or try to adjust myself. Again, there is a bit of a delay, so your question may not get to me immediately. And once it does get to me, you may not hear me answer it for a little bit, but I will get to it as I can. Okay, so the next thing that we want to do is fill out these statistics. And so we're doing these by group. And so what we're going to do is we're going to take the males and the females, and we're going to look at some of these descriptive statistics and how they're different for males and females. And we're also going to look at how they're different by race, so for white, black, and Latino participants. And then we're going to do the same thing for the BMI statistics. The first thing we need to do, though, in order to calculate any of this, is to figure out is to group things by males and females. And so the first thing we want to know, which we already know for males and females, that we have 10 of each. But if we didn't know that, we could use this function. So we used the count function earlier just to count the total number of cells that we've selected. In this case, there's another function that's called count if. And so if we do count if, that's going to count something when a certain thing is true. So the first thing that we're going to put in here is the range. So we're going to say count if, and in this case, we want to count the number of males and females. So we're going to select all of the genders, and then we're going to put a comma, and then we're going to put our criteria. So in this case, the row that we're in is the males. So we want to count if the variable says male. So we type in male in quotes. and then it tells us we have 10 males. We can do the same thing here, count if. We select these again, comma, and then we put in female. So count the number of cells that say female in them. And again, as we already knew, this is going to be 10. Now, we already know that there are 20 cases in here, so we already know that these are each going to be 50%. But were we not to know that, we could then take the count and divide it by, so the count in this cell, which is the number of males, and we can divide it by, so equals this, which is 10, divided by the count, no if here, of all of these cells, which again, we already know is 20, but if we didn't know that, this would help us figure that out. So we would take the number of males divided by the total number of people, and that's the percentage 10 divided by 20 division by 0. Seems not to be counting any of these for some reason. And I don't know why that is. Let's see, show calculation steps, 10 divided by 0. So by the way, if you're having a problem, you can click on that. So you click on the little warning button here, and then you can do show calculation steps, and it tells you what it's doing in there. So what it says is it's taking 10 and dividing it by 0. So apparently we cannot count the number of it's possible that we can't count the number of a text field. So instead, what I'm going to do is delete this and ask it to count the number of IDs. And so then again, of course, what we see is this is 0.5. And now I just want to show you quickly that in Excel, you have these formatting options. So you see we have number here, and we have a lot of different options of different ways we can format numbers. So we have here a proportion. So it's 0.5, which corresponds to 50%. If we want to change that to percent, we can just click this percent style here, and that'll make it 50%. And then again, we're going to take this count, and we're going to divide it by the total count of ID numbers, since you cannot count these text fields. And again, we get 0.5, and we can hit this percent here, and that'll turn that to percentages. We then want to take the mean, but we only want the mean for males, and then we only want the mean for females. And so the easiest way to do that is to go ahead and just sort the data by male and female. And so now we have the data sorted, so the 10 females are first and the 10 males are second. So now all we have to do here is take our average and do it just for the males. And remember, the males are at the bottom here. So we're going to do it just for the males, the average of age, the median age, the mode age, mode.single. Now, we probably will not have a modal age for either of these groups, because remember, 50 is the only age that repeats, and let's see, and one of the males is 50 and one of the females is 50. So we won't have a modal value in either of these groups. We want to take the minimum age for males and the maximum age for males. And then we want to calculate the percentile.inc of the ages for males, comma, 0.25 for the 25th percentile. And then we want to do equals percentile.inc of the ages for males, comma, 0.7, oops, comma, 0.75. Okay. So then we're going to do the same thing for females. So we're going to take the average of the ages for the females. And we're going to take the median of the ages for the females. And we're going to take the mode of the females, although we already know that there's not going to be a modal value for the females either. We're going to take the minimum of the ages for the females. We're going to take the maximum of the ages for the females. We're going to take the percentile.inc of the ages for the females, comma, 0.25. And we're going to take the percentile.inc of the ages for the females, comma, 0.75. All right. So now we have all this information, and what can we see? Well, first of all, we can see that on average, women are older than men in this sample. So women are on average 47 and almost a half years old, whereas men on average are 45 years old. So women are older than men in this sample, and they're older by about 2.4 years. We see it the same thing. So if these data were really non-normally distributed, which we'll talk about more in future sessions, but if these data are really non-normally distributed, the mean and the median will be the mean will be pulled more towards the skewed end of the distribution. And so sometimes the median can give you a more realistic sense if one of these groups had a very skewed range of ages, excuse me. But again, what we're seeing here is that on average, the median age among women and between women and men is a difference of 2.5 years as well. Although we do see that the median age is slightly higher among both women and men by about 3 years. So the mean and the median have a difference of about 3 years in this case. So the mean is being pulled more towards the younger years, which probably indicates that we have a little bit of skew towards younger ages here. Again, no modal age for either group. Not surprisingly, because men are younger, we're also seeing that the minimum age for men is also lower, so it's lower by about 3 years. We're also seeing, not surprisingly, that women have a higher maximum. So women on average, the maximum is 71 years, whereas for men it's 69 years. And then the interquartile range, although interestingly, you can see here that the 25th percentile is almost identical for both groups. A little bit more evidence that maybe these are skewed, that the 25th percentile is corresponding across the two groups, whereas the minimum value is lower. And here, the 75th percentiles definitely do not match. And so we see that women on average are 4.5 years younger with regard to the 75th percentile. Okay, so that was looking at our age statistics by gender. And then I also would like to look at the age statistics by race. So first I'm going to sort again by ID, and then this time I'm going to sort A to Z by race. And so we have our Black participants, then we have our Latino participants, and we have our white participants. And we do not know, without eyeballing it or counting it right now, how many of them are each. So the first thing we're going to do is our count if. And we're going to select all of, all of these, and if white, because this is the row for white. So we have 8 white participants. Now, the thing is, I can copy this and I can drag it down. But as I showed you before, what it's going to do is, in this case, it moves down the box. So we could move the box back up manually for each one. Again, move. So see here, it moved the box down by 2 because the formula had been moved down 2 rows. So we could move that box back up by 2. But there is something else that we could do here as well. Also, by the way, we would need to change the values in here so that this row said Latino and this row said Black. However, I'm going to delete both of those because I'm going to show you something else that you can do. When you have these ranges of values in here, C2 to C21, the colon indicating that we're going for the full range of C2 to C21, there are ways of also indicating that you would like to include other sets of data in that range as well. But C2 to C21 says that we're going from column C, row 2 to column C, row 21. But this could say column C, row 2 to column D, row 21. Oops. In which case, you'll see that the box then moves because I said column C, row 2 to column D, row 21. So now it's going row 2 in column C down, and then it's going back over to row D or column D until it gets down to row 21. So I just moved the box simply by changing that C to a D. So what you can do here is actually put dollar signs in front of, if we wanted to make it so that the column did not change, we could put dollar signs in front of the C's. And if we did that, then if we moved this statement horizontally across the columns, it would keep everything in this column. The column would not move. In this case, what we actually want is for the box to stay the same vertically. So what we don't want it to do is move up and down when we move the function up and down. We want it to stay exactly C2 to C21. So what we're going to do is we're going to put C $2, which means column C. Well, actually, in this case, we can put dollar signs in front of both of them. So $C, $2 means only start at C2 no matter where we drag this. The first value is going to be in C2. And we can do, again, $C, $21, and that's going to say always end in box C21 no matter where I move this. It's going to basically tell Excel, do not update the thing that comes after the dollar sign. So do not update that we're looking at column C. In this case, do not update that we're looking at row 2. Do not update that we're looking at column C. Do not update that we're looking at column or row 21. Okay, so now if I drag this down, it's going to keep giving us 8s for now because what I need to do in here is go in. But notice now I dragged it, but now it hasn't moved the box at all because we told it do not move the box from column C, row 2, column C, row 21. All right, so now all I have to do here is change this to the word black and change this to the word Latino. And now we can see we have 8 white participants, 7 black participants, and 5 Latino participants. And now we want to know what percent of the data set is that. So we're going to do equals this number, and then we want to divide it by the total count of all the ID numbers. But again, we're going to want to move this function down to the next set of rows so we can put our dollar signs in there. In this case, it's really only necessary to put dollar signs in front of the row numbers because we're not taking this formula and moving it horizontally across the columns. If we're moving it across the columns, then we need to tell it to keep the columns the same too. But we only intend to move it up and down the rows. So all we really need to tell it to keep stable is the range of rows. All right, so we're going to do the equals J6 divided by the count of ID numbers. Now, if we move that same function down, we can see that it updated this to J7, but it did not update the box over here at all because we told it stay within row 2 and row 21. Do not go up and down above 2 or below 21 within the column that we're referencing. And same here. You can see that it updated it so that J8 is this box down here now because the formula is here, so it moves down 1 box, but it did not update the green box over here. All right, and then don't forget, we want to change the style of these so that we're getting percents out of them. And so we can see that having 8 out of 20 corresponds to 40%, having 7 out of 20 corresponds to 35%, having 5 out of 20 corresponds to 25%. All right. And now we already have these data sorted, so it'll be very easy to calculate the means. We're just going to do equals the average of the ages for white participants equals the average of the ages for our black participants and equals the average of the ages for our Latino participants. All right. Now, I just want to also show you something nice. So in this case, you can see that we have this variable has a lot of decimal places, and decimal places can be annoying to deal with. And so if you have a lot of decimal places and you don't want to see them all you have to do is use these 2 buttons up here. This first button tells Excel to increase the decimals, so it will give you even more decimal places. And this button tells Excel to decrease the decimals, so it will give you fewer decimal places, and it will round. Now, Excel is always still storing the full number in the background, but this basically just adjusts what it's showing you. And so if we do this and we do it a couple of times, you can see that then we will end up with just 34.4. Now, if we always only want one decimal place, we could highlight all of this and then just do this, asking it to always give us 0 decimal places, always give us 1 decimal place, etc. And now, of course, that turned off the percent function because percents don't have these percents don't have decimal places. So I'm going to put that back on. All right. Next, we want the median of the ages for the white participants. The median. Oops, forgot my equal sign. You always have to have an equal sign there, or it'll assume you're just typing a little note. Equals the median of the ages for the black participants, and equals the median of the ages for the Latino participants. Equals the mode of the ages for the white participants. Again, in this case, we most likely will not have a modal value because I believe one of the participants, one of the 50-year-olds is Latino, the other one is black, so we will not have a modal value for any of these, but I will just put it in there anyway, just so that you have it. Have the formula, that is. Okay, and then equals the minimum for the white participants, equals the minimum for the black participants, and equals the minimum for the Latino participants. And then finally, or not finally rather, equals the maximum for the white participants, equals the maximum for the black participants, equals the maximum for the Latino participants. And then we want our percentiles again, equals percentile.inc for the ages of the white participants, comma 0.25 for the 25th percentile, equals percentile.inc of the ages for the black participants, comma 0.25, equals percentile.inc the ages for the Latino participants, comma 0.25, equals percentile.inc the ages for the white participants. Now I could have moved this formula over, but then I would have had to move the box back and I would have had to change the K to be 0.75. So it's not that much more work to just type it all out. Equals percentile. Okay, so now looking at this, we can see that on average, our white participants are the oldest, our black participants are the youngest, and our Latino participants are in the middle. This comes through very nicely with the median as well. It comes through not quite as clearly with the minimum. So the youngest black person is 20, but the youngest white and Latino people are 27. Although we did not have repeating ages, so this may have accidentally, nope. Huh. I did not realize up until now that we had two 27-year-olds. So in addition to having two 50-year-olds, apparently we also have two 20-year-olds or 27-year-olds. However, again, the 27-year-olds are in different racial groups and in different age groups, which is why we still did not get a mode for those. And then for the maximum, you can see that the Latino participants actually have the oldest participant in the data set, even though they're not the oldest group. And then come the white participants, and the oldest Black participant is actually only 50. And then we see the interquartile range for this is about 52 to 64, 27 to 43, and 40 to 51. So those are some interesting numbers there. However, these numbers can be a little bit hard to interpret. So the one nice thing about Excel is its ability to plot this information to make it a little bit easier to understand. So the easiest way to plot these data to make them a little bit more clear to understand is by simply plotting the means by group. You could either plot the means or the medians. That's totally up to you. In fact, I'll show you how to plot both. Excuse me. Before we start plotting, we really want to select what exactly we want to plot. And we always want to include the labels for what we're plotting. So in this case, we want to plot this information. We want to plot the means and the medians for males and females. And we want these labels of mean and median to be included, but we also want to know who's who. And so I'm going to hit Control. Control tells Excel that I'm still selecting things, but they're in a different place where I can't just easily drag it. I'm going to hit Control and then select over here as well. And then that's going to allow me to select these labels in addition to the mean and median labels. I'm then going to go up here to the Insert, and I'm just going to do Column, and then I'm just going to do the very first one, which is Clustered Column. It's then going to put in a nice bar chart for me. Now, unfortunately, it did not correctly indicate which groups were which. So let's go in here to Select Data. And we might actually want to remove. So edit. Oops. So it's not showing us anything for Series 3 and Series 4. I'm not sure why it automatically selected those. I'm going to go ahead and remove Series 3 and remove Series 4. I'm then going to edit Series 1. And Series 1, as you can see now, are the males. So what I did there was I said Series 1. And by the way, let me just go back. I'm in Select Data, which is what you can do once you've made a chart. If you realize you want to include more stuff or you want to remove some of the stuff, select Data. It's going to show you what data it's including. I can now edit Series 3. So let me go back. I clicked on Series 3. I clicked Edit. I'm now actually going to press this button and do this. And so what you can see here is that Series 3 is just this cell which says males. So I'm actually going to go ahead and cancel this and delete Series 3 because it's not a data point. And the same thing is true of Series 4 if we look at that. So if we click this, you can see that what it's dancing around over here, what it's kind of highlighting with a ring, is just the cell that says females. And so that's also not helpful. So I'm going to remove Series 4. I'm then going to do edit for Series 1. And if I do this now, it shows me around these two values. So what I now see is that Series 4 is the row corresponding to males. So I'm going to do that, and I'm going to click in Series Name. This was the series value. So this was showing me exactly what data points this corresponds with. I'm going to do Series Name. So it did not actually automatically select this for me. So I'm going to do the cell that corresponds with the word males for Series 1. And hit OK. I'm then going to edit Series 2. I'm going to look at what it corresponds to. And as you can see, the values that it's plotting for Series 2 are these two values for females. So I want the name for this group to be females. So I go to Series Name, and I click this button, which tells Excel that I would now want to select the cells. And I click the one that says females. And now, as you can see, if I hit OK, we have this nice plot where what it's done for us is it has said blue is males, red is females. These are the means and these are the medians. And over here we have the ages. And we can do other nice things to these plots. For example, if I go over here to the word format, so I'm up here in chart tools. So when you have if you're not using a chart, that chart tools thing is not there. But as soon as you click on a chart, Excel is going to automatically bring up this extra menu called chart tools. You can go to format, or I'm sorry, layout, and say that I want to add a title to this axis that says age. So I want to do a primary vertical axis title. I'm going to have my title rotated, which means, as you'll see, it's going vertically as opposed to horizontally. I'm going to click in there and I'm going to change the title to be age. So now we have a chart that says, what is the age for males, blue, or females, red? And what is the mean age and what is the median age for these groups? And so the mean age, as we can see, which we already know from the table, is about 54, and the mean age, or the median age, is about 56. The mean age for females is just under 40, it's about 39, and the median age for females is just under 35, it's about 34. All right, so now we can do the same thing for race. So I'm not actually going to include these this time because it didn't seem to actually work out in this case. So I'm going to select those after the fact. So I'm going to go ahead and select the data. I'm going to insert my chart, and then I'm going to select data. Oh, and see, in this case, actually, it reversed what it did. And so if we want it to be the same way, where it's showing us mean, median, in this case, the presentation of these doesn't make a whole lot of difference whether this is males and this is females and blue is median and red is mean, or whether this is the way it is, mean with blue and red for male and female, and then median with blue and red for male and female. Doesn't make a whole lot of difference in this case. With some types of data or some variables, those kinds of stylistic things will make more of a difference. In this case, it doesn't make more of a difference, so I'm actually going to leave this the way that it is so that you can see kind of the difference that we get when we look at the chart differently. But I will just point out that if you just do this button here, switch row and column, then what it does is it presents things the exact same way that we had before. So let's do it the new way first, and then we'll change it. So here what we want to do is we want to add the race ethnicity names to these labels. So instead of 1, 2, 3, we have black, white, and Latino. So I'm going to hit edit, and we are talking about group 1, which is white. Oops, I'm sorry. So white. Oh, I'm sorry. What I actually need to do is I'm going to be editing this entire range. So what I need to do instead is just select all 3 of these. And that's now, I'm doing an axis label range, not just an axis label. So now that I've done that, I hit OK, and what you see here is it's applied white, black, and Latino. Now, this doesn't give us the same comparison that we got up here. It's actually kind of in this chart maybe a little bit more helpful to show the means next to each other and be able to compare them right next to each other, and then to show the medians and be able to do the same thing. So what we can see here, not surprisingly, what you want to do is you want to cluster together on the thing that you're expecting them to differ by. So we're not expecting the white group, the black group, and the Latino group to differ among themselves on their mean and median. What we're expecting is the white group, the black group, and the Latino group to differ between each other on their means and on their medians. So what I'm going to do here is I'm going to go back to select data, and I'm actually going to switch these. And now what we're getting is a nicer display where we can see that on both the mean and the median, white is the highest group, black is the lowest group, and Latino is in the middle. And we already knew that from looking at the data, but this makes it a lot easier when we're looking at it visually. Okay, so that is actually all that I have planned for this evening. I have this down here, which is an exercise that you can do for the BMI. You can utilize some of the techniques that we've talked about tonight. You can go back and watch the video again to see some of the things that I did to move things over, to keep the column the same, to keep the row the same when you're moving things, when you're moving formulas. But feel free to try this formula out on your own time. Like I said, once I can get back onto Blackboard and post things, I will actually post a full version of this spreadsheet with the answers for BMI as well. so that you can see them. But I did want to give you an opportunity to take some time to practice what we've done here. This is really the exact same thing, but using a different variable. And all of these things will be really good practice for what you're eventually going to have to do for your assignment. As I said before, I didn't get any Q&A tonight, so that's totally fine. If you do have questions, or if you go to watch this video later and you notice that it was recorded with any sound problems or any video problems or anything like that, please send me an email. Comments on the YouTube video are not going to be as I'm not going to see them as easily or as often. I believe there's probably a Blackboard discussion board where you could also post, but email is definitely going to be the fastest and easiest way to get in touch with me. And my email address is HREN as in Nancy, DIN as in Nancy, A at hunter.cuny.edu. So HRendina at hunter.cuny.edu. So it's not J Rendina, it's H Rendina. And so that is it for this evening. I hope all of you have a good night, and I will talk to you next week.